Okay, so welcome to the fourth lecture on power system operation and control. Here we are again continuing with introduction, but it is we are moving more into the technical parts of a power system, and we will be discussing more technical details here in this lecture, and this will be even more interesting for everyone. So, if you have any queries from the previous lecture, you can let me know. Okay, now my pen is working. Perfect. Okay. So we have seen control and power systems in our previous lecture. If you have any queries or any doubts, you can ask me now. So we have seen all these details in our previous lecture. I generally keep the previous lecture here just to recap everything what we have studied in the previous lecture. So we saw till control objectives. Right. Now let us start with security analysis. So this is going to be our topic for today, and we will be also be looking how security is seen by a system operator or seen at a control center. So, so if you see broadly, security means absence from danger, right? If you see the grammatical meaning of security, it means that security absence from danger. And there is another term which is known as reliability, which also implies security, right? Because if I say that our system is reliable, that means we are continuously getting a power supply, right? If we are getting a power supply continuously, that means we say our system is reliable. Now if that is the situation, if system is reliable, that means system is naturally secure, right? There is no issues happening with the system. So what is the difference between security and reliability? Can you guess that, or can you think of that? Anyone? Can you guys hear me? Means is it am I audible to everyone?
Yes,
Okay,
the
okay. Good.
reliability meaning the system can restore uh, the
Means whenever fault has happened, you mean to say that
reliability.
system.
Yeah, when the change happen, the reliability will restore the stability for the system.
Yes, that also the reliability has another meaning. You can say that if a contingency or a fault has taken place, then how fast a system can come back to a normal state. You can also call that as reliability, right?
Yeah,
So basic difference from security and reliability is just as you said, security is a planning concept, because actually you are not, you are a priori, let's say, because it would be giving a good example like COVID is uh, across the world now. To secure ourselves, what we will do, we'll wear masks, we'll sanitize our hands. That is a security action. Now if you want to be reliable, so let's say in real time, if let's say someone, if we are traveling or if we are walking, if someone next to us, they sneeze or they cough, then immediately your reaction will be to make yourself away from him or keep a distance from that person. So that is basically reliability, so that you are ensuring that at least possible you you get a chance for getting infected. So that is the reliability difference between security and reliability. So if you think broadly, security is a planning concept. Before actually things are taking place, you are taking a precaution, that is called security, which is a planning concept. And when you are actually running a system, or you are actually in real time, you are thinking, okay, now what I have to do. And if in during that time you whenever you take an action, that will ensure your reliability. So I hope this terminology difference you got, the difference between security and reliability. So that's what Now, coming back to the security analysis, just by the term, you can imagine that this is a security analysis, not a reliability analysis. So, security analysis means in planning, during planning stage, we are ensuring that our system is secure. Got my point? So whatever study we are going to see in the coming up slides today, all will be on the planning stage, not on the real time. So there is a small difference here. Just keep a note of it. That's why I mentioned these 2 points to make you aware what exactly security analysis mean. Okay. Now we got the idea, okay, what is the difference between security and reliability? We got the idea what do we mean by security analysis. Now when we say security, it means that it implies absence from danger. Now the question is, danger from what? What is the source of danger? Can anybody guess that?
Yeah, I think it's faults, storms, breaking a mechanical failure of insulation.
Yeah. So broadly, whenever we say faults, which we can call it as contingency, or in general, contingency happens either on line or a generator. So line includes everything. Means if the contingency is happening at a substation, that means it is happening on a line. Means line, I am calling it as a broad term, but yes, substation is also there in that. All the isolators, a lot of equipments are connected on a line. Those all can get out and damage the system. So I'm including everything in line. And generator means if there is a fault at the generator substation or at a generator terminal or inside a generator, so all those outages I'm calling as a generator outage. Perfect. So danger from line contingency, which can happen either from line outage or generator outage. So we have to ensure in this security analysis, we will see that how we can ensure that these outages, if obviously we cannot 100% guarantee that okay, these outages will not happen. That is not possible. So right, we will ensure if that happens, how we can make our system secure and bring back to the normal state. So that is what we are going to see in this security analysis. Another danger which can happen is overload. Overload means most of the lines, let's say if a transmission line is there which has a capacity of 100 megawatt, right? So generally when you say this 100 megawatt, this number, actually practically this line can take, let's say, 150 megawatt from the manufacturer's rating point of view, but we still operate at a limit of 100 megawatt because we want to keep a safety margin. So generally 1.5 times or 0.2 for 25% or 10%, it depends on system operator to operator. They keep some small margin as a safety margin. So whenever this 100 megawatt or the power flow on this line increases this 100 megawatt or crosses this 100 megawatt barrier, then we call that this line is becoming overloaded, and we have to ensure that this line comes back to the power flow in this line comes back below to the 100 less than 100 megawatt. So this also is a security feature because we want to ensure that the power should not flow beyond a particular limit. So this also is known as overloading. I'm not sure if you are aware of this or not, but in India there was a big blackout happened in 2012, and during that big blackout, almost North India, Eastern India, and the Western India, complete blackout happened, and that complete blackout happened just because of one single line. And in that line was having actually the capacity of power is there is I don't know because most of you are from outside India, but there is probably the Indian people or Indian students might connect with it. So there is a city called Agra and there is a city called Gwalior. So there is a big transmission line connecting this Agra and Gwalior, and this line was actually overloaded. So this line was having capacity of 3,500 megawatts. So this was the capacity of the line, and during the time when the blackout was taking place, that time on this line around 4,000 megawatt of power was flowing actually. So because this 500 megawatt additional power was flowing on this, and there was obviously a lot of parallel reasons were there, but one of the major reason was this high power was flowing on this line, and the safety margin was 500 megawatts, and this 4,000 megawatt, even the power flow was even further increasing and going beyond 4,000 megawatt. So as soon as it was increasing gradually and going above 4,000 megawatt, immediately the protection or the circuit breakers which were connected on these lines, these circuit breakers went off or switched off this line. And as soon as you can imagine, if this big line which is having flow of 4,000 megawatt, if this line gets switched off, then what will happen? Because power flows based on Kirchhoff laws, all the power flowing on this line will be flowing through other transmission line. It will reach in this area. There will be some other parallel lines where the power will increase, and those parallel lines were not having this much capacity to handle. And there again, those circuit breakers connecting those lines, they also went off, and gradually cascading thing happened, and all the transmission line went off, and because of that a big blackout took place. Right. So this is another source of danger. And there is an extreme case when contingency and overloading both happens in parallel. So that is actually happened during the North India blackout in this Agra Gwalior corridor when it went off. So you can easily guess here what is endangered here. What do we want to secure? So this is again very clear. All the equipments, either line or generator, and also we have to ensure that the system does not move into instability or does not go into collapse. So we have to ensure the system as a whole, and also we have to ensure all the line and generator. Right. So during this lecture today, we will be seeing about all these security analysis in brief, and then later on, so because this is all introduction, so I'm still taking you as a briefly, and then later on. So have you ever seen a control center before? Have you seen a control center before?
No.
Okay. So basically a control center looks like this, what you are seeing in both the diagrams. There is a very big screen which you are seeing here, or this is also a big screen. There they have all the, you can see here that this is a diagram. This is a bit small diagram, but yeah, this is lot of lines are displayed. Basically all the information about the network is shown here. Also you can see a geographical network is there, and all the information is shown here, but it is very small to see. And there are few persons, or we call them as a system operator. They are sitting here. You can see here they are sitting here, and they have small computers where they see more details in detail, and they have, you can see here, telephones are there, and these in case of any emergency, they immediately call that substation and they inquire that, okay, is this actually happening or not, and then if he says yes it is happening, then they immediately take an action. So this control center is responsible for taking all the actions. So whatever things are happening, whatever, we have a lot of SCADA equipments installed, those are measurement devices, and those measurement devices, they transmit all the information to this control center. And as soon as a data is received at a control center, this data is processed immediately, and then an action is decided. If everything is normal, then no action is required. If anything is abnormal, then immediately, these systems are generally very smart. these systems immediately switch on an alarm stating that okay, there is some issue. So generally, if the diagram what you're seeing here, if some alarm is there, so then that line or that bus bar or that circuit breaker will start blinking in red. So that means you have to take an immediate action. So this is the control center, and basically we are going to see what all are the security functions at control center, what security this control centers ensure. So firstly, it is very clear that there are softwares which actually gets the data from the control center, from the measurement devices, and using that data they immediately process that data and then give you the actual values of voltages, angles, power flowing, so that you can judge or evaluate that is it an alarming situation or not. So to do this, there are broad three features what they follow, and we will be seeing these features in detail gradually in the course, and right now in brief. So the primary feature is monitoring. So monitoring means they, whatever the data is coming to that system, they ensure that we can estimate the present state of the power system. Present state means whenever we call it as a state of the power system is voltage, magnitude and angle. So that is the primary states what we want to know, because if you know the voltages and angle of a system at every buses, then you can estimate all the values you can estimate from that, if you know the voltages and angle, because you already know the impedances of the line, so you can easily calculate the power flow, you know the you can easily estimate the current of the line, everything you can identify if you know the voltage, magnitude and angle. The next feature is security analysis. Now in the security analysis, you exactly do this extensive what if analysis. What if analysis means it is in simple. Let's say if you are a system operator and sitting in a control center, so your job will be to see if this happens, then what action you have to take. If that happens, then which action you will be taking. So you will do all these situations, basically if else, if this happens, what I have to do, if this happens, what I have to do. So this is actually known as extensive what if analysis. What if this happens, then what action I have to take, what if this happens, what action I have to take. Most of the time it will be obviously normal actions, because you do not have to take action, but only in case of any situation, any specific contingency happens, then you have to take some action, right? And the last is security enhancement. Enhancement means basically whatever is the level of security at this moment, you want to enhance the level of security, and to do that you will be doing security constraint optimization. You will be doing solving a problem, and this problem will give you a insurance kind of thing, that if a particular contingency is taking place, even then your system will not get affected at all. And this again we are going to see a bit later on this course, not today but a bit later on this course, that how exactly solve means you can actually tell a system to run at a particular value which will not affect if a particular contingency takes place. So this will be this might be a bit difficult for you to visualize right now, but things will be clear as we move on. Probably 3-4 lectures down the line we will be seeing this security constraint optimization in detail. So just bear with me for a while. So again, just coming back to the monitoring in detail. So monitoring has two stages. First stage is whatever data is coming from the SCADA, you actually process it and immediately give a alarm signal. You immediately give alarm signals if there is a abnormality. If everything is normal, obviously you do not have to give. If there is anything abnormal, then you immediately give a alarm signal. And the second stage is state estimation. So I'm not sure, are you aware of state estimation? What exactly happens in the state estimation? Anybody? Okay, so I am assuming that
Is it related?
Please go ahead.
I think it is related to load flow parameters and in the network.
Perfect. Yeah, exactly. It is equivalent. I won't call it exactly same as load flow. It is equivalent to load flow. But in load flow, you have to give PV bus, PQ bus, slack bus. But in state estimation, you do not have to give any of these sort. You do not need to give specify slack bus, PV bus, and PQ bus. So state estimation you will anyway be studying in CAPSA course, your computer aided power system analysis course, what Professor Pardy is taking. So you will anyway get to know that from there. But state estimation is nothing but just to estimate the states, which is voltage, magnitude, and angle. So these states are estimated based on the data what is coming from the SCADA systems, and once you estimate these states, you can evaluate the informations of the complete system. You can get the current values, you can get the power values, everything you can get if you know the voltage, magnitudes, and angle. So this is what is done in state estimation, and this is a very fast process, similar to load flow. Load flow is obviously very fast, but similar to load flow, state estimation is also very fast. At the control center, in India also, the state estimation happens in every 1 minute. They do the state estimation. In US, in Europe, they have even more advanced systems, so they go for every 10-15 seconds they go for one run of state estimation to ensure everything is fine. Right, so this is what is known as state estimation. So these are the monitoring features of security function. Now the second what I mentioned is security analysis. Here what they do is extensive what if analysis. What if analysis means the situations which can actually damage the system, or which can raise an alarm in terms of security of the system. So these situations are like this: any contingencies or scenarios which can take place. So contingencies, you are aware, contingencies are either line outage or generator outage. Scenarios means basically if sudden load change happens. Load change means, let's say for example, let's say suddenly it was planned that today it is going to be or tomorrow, let's take tomorrow it is planned that okay, it is going to rain a bit. So if it is going to rain, that means you can imagine that most of the people in this city, let's say if I'm talking about Roorkee, here most of the people will not be using air conditioners, and if there is and eventually the load will be very less of the city. But let's say tomorrow rain does not happen, and if that rain is not happening, then suddenly obviously most of the people will switch on their air conditioners and suddenly load will increase, right? As soon as this, because of this forecast error, if the load increase is huge, imagine the load increase of a big city, then this can take a serious implication on a system. So these scenarios also we consider, right? You also consider probability of occurrences. This is basically you see that okay, what is the probability of a particular contingency to happen, or to load change to happen, or a forecast error to happen. So this also you take into consideration while doing the security analysis. Another is N-1 criteria. Anybody aware of N-1 criteria? What exactly we mean by N-1 criteria? This we are going to see a lot during this course. But
I think it is related to contingency analysis when one device is be outage of.
Exactly. Perfect. Good. So basically, when we say N, that means all the components which are connected in the network are working fine. All the components are working fine. Right? There is nothing damage here. Now when we say N-1, that means one of the equipments are out or failed or damaged, whatever it is. So one is damaged, rest all is working fine. So whenever we say N-1, we always say, because we always ensure that the system should be one of the system should always work even when one of the appliances or equipment or apparatus is switched off or outaged. So we always ensure n-1 criteria. That is the control of centers criteria. Generally, all the system operator ensures that one of the system should work even if one of the equipment or appliances switched gets damaged or failed. And lastly, obviously, there is a factor of experience which plays a very big role, because power system is so huge. You can imagine the size of Indian power system. You can imagine size of US power systems. You can imagine the size of Australian power systems, European power system. They are really huge. Now, if you see this huge power system, and just one control center is operating this big system, so there is a lot of things which you cannot predict, which you cannot evaluate just by mathematics. So you need a bit of experience here. So from the past, if let's say a system operator is constantly observing that, okay, this line is always getting overloaded, so he will ensure additional security for that line, that because this is getting overloaded often, that there is a probability that this might get and obviously that India is a developing country, so most of the cities are getting expanded, so new buildings are coming up, new industries are coming up, so the load is always increasing in India. And if the load is always increasing, and if a line is seen by a system operator that it is often getting overloaded, that means in future it will be crossing its operating limit. So here, what they do is, in security function, in this security analysis, they actually, all these scenarios, all these list of scenarios, they study them in real time, in day ahead, in unit commitment. Anyway, unit commitment, I'm sure you must have studied a brief about it in your bachelor's, but we'll be seeing them in detail in this course. And HTS is hydrothermal scheduling. This also we'll be seeing in detail in this course. Sorry. Sorry, just a second. Okay, so yeah, sorry, I don't know, something happening to me daily morning. Okay, so just a second. Okay, so okay, so because of large number, there are the because the size of the system is large. Sorry. Okay, sorry. Yeah, just a minute, please. Okay, yeah, sorry. Again, just coming back to the normal. Yeah. Okay, so because of this large number of contingency, you can. Okay, so as I was telling you before, that in this security analysis, we see this n minus one criteria and everything. And when all these scenarios or situations, what we take care in real time, day ahead, unit commitment, and hydrothermal scheduling. And you can imagine the size in terms of number of contingencies, what you have to look for. So there will be huge number of contingents. So for example, let's say I can tell you from the Indian power system point of view, in India there are more than 11,000 transmission lines, and this I'm only talking about the transmission lines. And there are around, if we talk about all the generators, so we have around more than 8,000 generators. So you can imagine this is just lines and generators. If I include transformers, probably there will be another 5,000 transformers across the country, and a lot of isolators, lot of small equipments which are connected across the lines. Fact devices are there. There are capacitors, series capacitors, series inductors. So all these things are there which can get damaged, and you have to consider all these factors. So you can imagine the size of everything which you have to consider. So basically what we do, it's a trade-off actually. Obviously we cannot include everything, otherwise this will be really problematic, because at the end you want to run the system, right? So for that we actually do a contingency ranking. Contingency ranking means whichever is the most probable to get out, or whichever is most probable to get violated or get damaged because of that outage. So those we denote as critical ones. And if they are, let's say if they are unaffected because of some contingencies, so then we call them as non-critical ones. So there are various equipments which will always remain unaffected because of contingencies. They are called as non-critical ones. So obviously you do not have to include those, and you have to only include only the critical ones. So this is what is done in security analysis. Now security enhancement is, as I told you before, that it is a security constraint, or we perform a security constraint optimization here. Now in this security constraint optimization, what we do, it is a two-step process. One is preventive rescheduling or preventive action plans and corrective action plans. So whenever we say preventive action plans and corrective action plans, again you can imagine from regular flu point of view, or any fever, let's say simple viral fever. If you have, what you do, you ensure all the hygiene and everything, so that you should not have a viral fever. So that is a preventive action what you are taking. So whenever if some whenever means you are keeping all yourself very protected. Whenever it is, let's say, winter time, you are covered with all your clothes so that you do not catch a winter and cold or anything. So that is all preventive action. Now if, let's say, corrective action means if you have a fever, if you have already got your fever, that means you have to ensure that if you have a fever, you need to have a some tablets or some medicine you want to keep yourself working, or keep or you want it to go means recover from the cough and cold as early as possible. So basically, the taking of those medicines is actually the corrective action plan. So, or in a simple sense, I can say buying a medicine, keeping at home is a preventive action plan. That, let's say, if a flu happens, I will be ready with the medicine. I do not have to go to hospital. I do not have to go to a pharmacy to get a medicine. I have a medicine at my home. That is a preventive action plan. And if a flu or viral fever happens to me, then I'll take that medicine. That is actually a corrective action plan. So you got the difference between preventive and corrective action plan. So similar to this, in power system also we do preventive and corrective action plans, where we say that if there is a contingency which is very critical, and if that contingency takes place, then we cannot do anything in real time. So obviously, let's say in COVID time, if COVID happens, because we were not having in initial days, we were not having any medication for that. So in initial days, we were really, our hands were closed, and we cannot do anything. So that's why we were all taking very preventive actions, and all the preventive actions was one of the most biggest impact was kind of lockdown. I'm not sure about other countries, but India had a very big lockdown. So because of that lockdown, a lot of economic losses and financial losses has happened. So you can imagine, whenever you take, and similar to this in power systems, whenever you take a preventive action, it is extremely expensive. Basically, it impacts the cost. It impacts the feasibility of the system. It impacts the at times it becomes really impossible to include everything in the preventive action plan. But there are still few situations where we include preventive action plans, and this we'll be seeing in detail how exactly we include that in the preventive action plan. Through examples we will see that. And in the corrective action plan, as I told you, that whenever a situation has already happened, then you take an action. So basically, you have a flu or a viral fever, then you are taking an action. So similarly, some contingency or ill effects has already taken place, and then you are taking some action to alleviate that or to remove that. So basically, for that you need to have a lookup table. Lookup table means you know that if that happens, what action I will be taking. So you will be prepared with lot of actions from the control power system point of view. At the control center, they have this lookup table, and they have a big file, which what they do is that they know that if this happens, let's say if a particular line gets out, then a system operator does not have to do all the study to know what action he has to take. He has already register available with him, and he know against that line there will be some action which will be mentioned, and he will just read that table and he will take that action. So it is as simple as that. So you have to prepare this lookup table. So preparing this lookup table is done in corrective action plan or corrective rescheduling. We will be seeing that in detail in the course. Just important to note here, both preventive and corrective action plan has to be very carefully managed, because both has cost implications. Both have cost implications. It will eventually increase the cost of the system, and as soon as the cost of the system increases, it will affect the electricity prices, what as a customer we pay our electricity bills. So that prices will go up if you do not coordinate well in preventive and corrective scheduling. So this is very important from the operational point of view. You have to be very sure that how you are taking care of this preventive and corrective action plan. And this we are going to see in detail using mathematics and solving problems. We'll be see that we'll be seeing this in detail during the course. Probably 4 or 5 lectures after we'll be seeing this. So probably I can start here. I missed some time, but I have still 10 minutes remaining. What I'll say, I'll continue with this for a while. Just I have 10 minutes remaining with me. Okay, so whatever you have seen this security function, this has an eventual goal to achieve the operating states and to ensure the operating states of a power system is always at a level where you can manage the system. So there was a big debate. Means I'm just taking you back to the history line, and in history there was no plan in power system which can say plan for the system operator or at the control center what has to be done when a particular situation happens. There was no plan. It was all working based on experience. There was no strategic action plans were available. There was no research was available till 1979. There was a scientist, and he's I think a French scientist. Yeah, he's a French scientist, and he developed a method. The scientist name is D. Liaco, and he developed for the first time that how exactly should be the states or states of the system has to be defined, and how a system operator or a person sitting at a control center will take action to bring the system back to a normal state. So this was proposed by D. Liaco in 1979, and then it was modified by Stott, Alan Stott. He was again a big scientist. He is an American scientist, and he developed this strategy. So whatever we are seeing here, this is developed by Alan Stott, and it was done somewhere in 1980s. Exactly, I do not remember, but yeah, sometime in 80s. So here, just to give you a brief, that there is a secure state, and if something happens, then the system move towards the downward arrow is basically means that a load or disturbance or contingency has taken place, and an upward arrow means control actions which improves the quality of the system. So let me draw by red, so that this means that there is some damage has happened. So whenever initially your system is in secure state, something happens, it moves to the correctively secure state. Then if something happens, then it can either move to the alert state or the correctable emergency state. So we'll be seeing what is the difference between those two in tomorrow's lecture. And then if it is in alert state, and if something more damage or some more severe thing happens, then it will move to the non-correctable emergency state. And if, let's say, if you are reaching at this state, then there is no option again you to come back to the normal. You have to take some restorative action. So let me just change the color here. Let me draw it with blue. So from here you will again take some control action to bring the system to the restorative state, and then you will take some control action to bring the system back to the alert state, and then again you will take some control action to bring back to the correctively secure state. Probably also from this correctable emergency state you can take some action to bring back to the correctable secure state, and then lastly you will take some action to bring the system back to the secure state. So let us stop here, and tomorrow we will be discussing what exactly these states mean, and what do I mean by these states when I say. So this is going to be an interesting lecture, what situation happens and how these states are defined, and at what situation which system will be means how will you define that what is the state of the system at this current situation. So this we are going to see in the tomorrow's lecture. I hope this is fine. So if there is any doubts, I can answer that or queries.
I have a question, please.
Yeah, sorry.
Yeah, I have a question. My
Yes,
question
please.
is,
Yes, please.
Can I is protection or protective device like relays and something or all protection, is it kind of security? Is
Uh,
the protection kind of
See, protection is a security from a damage. So I can give you a simple example. Let's say if there is this transmission line is there, and there are circuit breakers installed at both these sides, right? Now, if this circuit breaker opens the line, imagine that this line is open, then what will happen? That this line will be protected from getting damage, right? Or let's say power is flowing on this line, and if this power is flowing, very excess of power is flowing on this line, that means this wire, because of this I square R heating, I square R T, so there will be heating, and this wire can catch fire. So during that time, what this circuit breaker will do, this circuit breaker will open this line, and it will save this line. So basically what you're doing, you are protecting this line. Now, as you said, this protection is actually protecting this line, but whatever power was flowing on this line, this will start flowing on the parallel lines, whatever, because obviously the system is huge and the system is all connected. It's a meshed network, so all the buses are some way or the other connected. So even I can say there is no direct line between northern and southern India, but through various transmission lines, all this complete power system is connected. So what will happen, whatever power was flowing on this line, it will be transferred to the neighboring lines, right? And whenever this transfer happens, who guarantees that the neighboring line, the power flowing on this neighboring line will be within limit? We cannot be sure that, right? We cannot be sure of that. So the line neighboring to that might also have a circuit breaker, and if the power flow is beyond a particular limit, then that line will also get switched off. And because protection devices will protect that device. So for example, if I'm sure you must have studied in protection, there are protection for generators, protection for lines, protection for transformers. So that protection devices are only protecting those equipments from damaging. But you have, because from the power system point of view, you have to think as a whole. Power system has to be secure. Do you get the difference here? Am I clear? Do you get the difference here? Protection devices are only
no, I get. Yeah.
Okay.
Asking about the difference between the protection is to protect device from the damage.
Yeah, protection is exactly protecting the devices from getting damaged, but it does not ensure that the complete system is secure or system is.
Yeah,
Do you get the difference? It is only for that protection of the device,
yeah, I get it.
but as a whole. So for example, I can say that if I don't know if you are driving a two-wheelers. If you drive a two-wheelers, especially in India, if you drive a two-wheelers, you need to wear a helmet. So helmet is only protecting your head or your face probably, but it is not protecting your hand or leg. You get my point?
Yeah.
So,
Yeah, I get it.
so protection is for the head, but your hands can. But if your head, even if your head does not get damaged, it does not guarantee that my hand cannot get damaged. It can also break, right? So that is the difference between protection and
Yeah.
security. And if you are traveling by four-wheeler, you are obviously more secure. You can imagine, you will not say that I am protected. You are more secure because there is less probability of any part of my body getting damaged in a car. But obviously there is also some percentage of risk is there, but yeah, that is different. But you get my point, right?
Yeah, I get it. Yeah,
Okay,
thank you.
perfect. Any other queries, or we can end this class? Okay, good. So see you on tomorrow's lecture, and yeah, so we'll be continuing from here. Operating states of a power system. I thought actually I'll complete it today, but because of I wasn't able to do it. Anyways, see you guys.